Okay, we are starting today on lesson 6.1, which is page 1 of your packet, doing reflections on the graph. There will be some things in this notes that I say and do not write down, so listen carefully. So when we reflect across the x-axis, our first step is to name the coordinates. So my A point, my x goes backwards 3, so that would be -3, I'm counting from the origin, and up 1, 2, 3, 4. My B, I go forward 1, 2, 3, 4, and up 1, 2. And C, I go over 1, 2, 3, and up 1, 2, 3, 4, 5, 6, 7. Over 3, up 7. Now if I want to reflect across the x-axis, this is my x-axis. And so if my A was up 4, I'm going to stay on that same line and just come down 4 instead. And so my new A point will be the same x coordinate, because that didn't change, I'm just reflecting it this direction. So it will still be -3, but I now have changed to -4. B is going to be the same thing, so we still are at x equals 4. Instead of going up 2, we come down 2. And so that gives me 4 and -2. And my C, I stay in the same x equals 3 and come down 7. 1, 2, 3, 4, 5, 6, 7. And so my C is still +3 for x, and now -7. I'm going to connect my dots, and look and see, that does look like I've just taken my drawing and flipped it over. So now looking at just our coordinates, if we were doing this without looking at the drawing at all, can you see a pattern of what we changed there? So on your paper, go ahead and write down what you think that pattern is. Okay, if you need to pause the video until you figure out the pattern, go ahead and push pause. We're going to move on to example 2. This time we're reflecting x, y, z across the y-axis. So this is our y-axis, our up and down one. And again, we're going to label our points first. So x is +2 and +1, 2, 3, 4. Y is +1, 2, 3, 4, 5, 6, and up 2. On your own paper, go ahead and fill in the coordinates for Z. Okay, so now I'm reflecting across the x-axis, and so x was forward 2 and up 4. And so for me to cross the y-axis, I just have to go backwards 2 and stay on the same +4. So my new x-coordinate is just -2 and still +4. My new y-coordinate, instead of +6, I'm going to go backwards 6. 1, 2, 3, 4, 5, 6. And it's still up 2. On your own paper, go ahead and write the new coordinates for Z, and then graph it. When you graph it, it should look like this. And so we check to see, it does look like we have the same triangle here, it's just been flipped over across a y-axis. Can you see a pattern with our points here? So with the point that I gave you and the one you figured out by yourself, can you see the pattern of what has changed? Go ahead and write that down. Okay, and then the next one is this time we're reflecting across our y equals x line. That's drawn there for us, y equals x. And so again, we start with labeling our points. This time, see if you can fill in the points before I do. right, and check and see if these are the ones that you have. And so for me to do this, okay, so on this one, to reflect across y equals x, what we're going to do is we're just going to flip our y and x coordinates. And as we draw this out, you'll see the pattern of how it works. So my s coordinate, which is the closest line, easiest to see, is -1, +2. And so instead, I'm going to go +2, -1. And that would be where it's reflected. We can see those if I do a straight line from that point to my y equals x line, straight line out here, I can see they're exactly the same distance from that line. My r is -4 up 6, and so I'm going to do +6 and then down 4. And again, if I were to take a ruler or something, I can see those are reflecting across that y equals x line. T, instead of -6 and -1, I'm going to come to -1 and then down 6. And so then I have my 3 new points. I connect them and see that does look correct. I've taken it and flipped it over. And so my points, I just switched them. And so my pattern is my x and y change places. So when you have that, go ahead and flip over to page 2. So on page 2, we have the summaries here for you. So when you wrote about the pattern on your page 1, you should have put something saying that the y point changes to negative. So our pattern for that, if you wanted to put words to it, I would write x stays the same, y changes sign. So if we're reflecting across the x-axis, x stays the same, y has to go to the opposite sign. So if it's positive, it goes to negative. If it's negative, it goes to positive. When we reflect it across the y-axis, it's completely the opposite. So I'm going to write that on this side. That would be y stays the same, and then x changes signs. And so hopefully what you wrote on the front had something to do with that, where you just recognize that we're changing the sign of the opposite whatever axis we're flipping over. And we already wrote this. If we're reflecting over line y equals x, we just flip the coordinates. This isn't one that you'll probably see in this assignment, but you may see it at some point in the future. If we're reflecting across the negative x line, then they flip and both become negative. So now lines of symmetry. Symmetry means they're exactly the same on either side. So if we go back to examples on page 1, we're going to say what lines are there that cut our examples exactly in half. And so if we look at example 1, my x would be my line of symmetry. This half is reflected exactly over onto this half. Example 2, it would be my y-axis. I'm taking this image and just reflecting it exactly over my y-axis. And example 3, it's my y equals x line, where I've taken it and flipped it exactly over there. Those are what we call those lines of symmetry. So when we're reflecting something, the line we reflected over is the line of symmetry. So that was my x-axis, my y-axis, and y equals x. So now we're going to find lines of symmetry just on some examples. So I'm going to do a couple with you, and you will do some with just by yourself and show it to your teacher. And so in the first one, nice smiley face, I can draw a line exactly down the middle. And see, each side is now equal. If I have, so there I had one line of symmetry. If I have this one, well, I could cut it in half this way. I could also connect these corners, cut them in half this way. I could cut them in half this way. That's 3 lines already. Could I also divide each side in half? If I do it this way, that's still equal halves on either side, and so I'm going to do that for every side. And so I had a total of 1, 2, 3, 4, 5, 6 lines here. And I did notice this was a regular hexagon with 6 sides, so if I have a regular hexagon, I will also have 6 lines of symmetry I can go through. Okay, so you're now going to finish up these last 4, draw the lines of symmetry, and write how many you have. And if you need to pause it to finish that, you can do that. C, you should have found 1 line of symmetry. D, you should have found 2. E, that was an extra D. This D would be 4 lines, so if you haven't found them, I'll see if you can find them. And E, the answer is none. There's no way you can draw a line and divide that figure exactly in half. So now you're going to go on and do your quick check and move on to the assignment the teacher gives you.